Okay, so using these Pythagorean identities to find an unknown trig value when we have been given a trig value is a very important skill. So let's do another example of trying to use that skill. In this case, we are told that the tangent of x equals 2, and x is some angle that's between 270 degrees and 360 degrees. Can you visualize where that is? Take a look here. Here is our Cartesian coordinate system. That would be 0 degrees. This would be 90 degrees. Here's 180. Here's 270 degrees. And there is all the way around is 360. So between 270 and 360 is here in the fourth quadrant. So x is a fourth quadrant angle. Which Pythagorean identity is going to be best for this problem? Well, you might remember that one of the Pythagorean identities was 1 plus the tangent squared x is equal to the secant squared x. Let's use this Pythagorean identity because in this case we are given a tangent, and this Pythagorean identity includes a tangent. Let's substitute and see what we can do to simplify. So 1 plus, instead of the tangent, I'm going to put what the tangent is, but I have to square it, is equal to the secant squared of x. Let's simplify what we have. So this is 1 plus 2 squared is 4 is equal to the secant squared of x, which means that 5 is equal to the secant squared of x. I'm just going to rewrite it this way because it's a little easier to look at. So secant squared of x is equal to 5. Let's take the square root of both sides. So the secant of x is equal to plus or minus the square root of 5. How are we going to find what we want to know? What is it we want to know? We want to find the cosine of x. Well, if the secant of x is plus or minus the square root of 5, that means that the cosine of x is equal to 1 over plus or minus the square root of 5. How are we going to decide if it's a plus or a minus? Well, let's go back to which quadrant we're in. We said that we were in the fourth quadrant. What is the SIGN of all of the x values in the fourth quadrant? When I'm over here, all of the x values are positive. Cosine depends upon the x. And so the cosine has to be positive, which means that the cosine of x must be 1 over radical 5. We don't like to leave radicals in the denominator, so I'm going to rationalize the denominator by multiplying by radical 5 over radical 5, which gives us radical 5 over 5. So when the tangent is equal to 2, and I'm in the fourth quadrant, we used this Pythagorean identity in order to find that the cosine is equal to radical 5 over 5. And if we wanted to, we could find the sine, the cosecant, and the cotangent just as easily.